Okay, we're doing these improper integrals. We have negative infinity to 0, and we've got z times e to the 2z. With this one, we have a product of two functions in here. We've got z times e to the 2z. So we're going to do integration by parts. With integration by parts, you want to make sure that whatever you let u be, it becomes simpler. So in this case, if we let u be e to the 2z, that doesn't become simpler. That's just 2 times e to the 2z. But if we let u be z, that does become simpler. So u is going to be z. Therefore, the derivative is dz. We're going to let dv be the rest of that, which is e to the 2z dz. V then becomes 1/2 e to the 2z, because we're integrating. So with integration by parts, we do u times v minus the integral of v du. So we have uv gives us z over 2 e to the 2z. That's uv minus the integral of v du. We have 1/2 outside, we've got e to the 2z dz. We integrate this, and we get e to the 2z over 2. We've already had a 1/2 over there, so this is minus this over 4. So now that we've integrated by parts, we could go ahead and work with our two separate pieces of this. We've got negative infinity to 0 of this. We've already integrated. It's negative infinity to 0 of this. We've already integrated, so now we're just doing the bounds for the entire thing. Remember, we can't directly work with negative infinity, so we're going to have to replace negative infinity with a variable. Let it be t, and then let the limit as t approaches negative infinity go on this. So now we plug in the bounds for both of these portions. We have one in which we have 0 plugged in for z, which is the first one. And we have one in which we have t plugged in for z. And that's the one we're subtracting. And the one in which we have 0, we get, what do we get here? We get 0 times e to the 2, 0 over 2 minus e to 2, 0 over 4. And the one in which we have t, we have t e to the 2t over 2 minus e to the 2t over 4. And we're letting the limit as t approaches negative infinity go on this thing. So this one doesn't even have t's, so it doesn't really matter that we're taking the limit as t approaches negative infinity. Over there, it really does matter. So you could write it over here, or you could just, it's really being to this entire thing. So over here, what do we get? We get 0 times anything is 0. It doesn't even matter. This is just 0. This becomes 0. This, you have a power of 0. That means this is 1. So you're subtracting negative 1/4. This becomes negative 1/4. Over here, this is we're doing negative infinity. So with this one, we're kind of going to need L'Hopital's rule, because we're still multiplying by a variable. We're multiplying t times e to something that goes to negative infinity. So let me show you what I'm saying here. This is what we have. Te to the 2t over 2. We're plugging in negative infinity for t. So this becomes negative. It becomes a negative exponent, which means that e is down here in the denominator, like this. 2e to the 2 infinity, like that, which is just infinity. You have something going to infinity in the denominator. And t, we can make this just be 1 by ze²ᶻdz rule. So we take the derivative of what's on top, and we take the derivative of what's on bottom. If we take the derivative of what's on bottom here, we still get just something going to infinity. So we have a denominator going to infinity, and we have a constant up here, so this goes to 0. This entire thing right here goes to 0. 0. This right here, we don't even need ze²ᶻdz rule. We could just notice that, again, we're plugging in negative infinity. That means that e to the 2t over 4, we're plugging in a negative infinity. That means this is in the denominator like this, e to the 2 infinity. And therefore, this is going to 0. But you got something really big going to infinity in the denominator. It's just constantly growing and growing and growing in the denominator. That means you're dividing by greater and greater quantities. You're just going to 0. So the answer is negative 1/4 minus 0. It's just negative 1/4. It converges to negative 1/4.